Good morning, guys. It's your first day back after half term, and we are going to be continuing looking at our statistics in our maths. And to get yourselves warmed up and back into how we do maths, we've got your starter here. There are two questions, both on fractions. So let's see what you remember. You need to think carefully about them. The second one, think why we can't compare or do anything with these numbers as they are. What might we have to do? But go and have a go at them in your home learning book, on a whiteboard, on your workings paper, however you've been doing it, and then come back and we will talk through the answers. Off we go. Perfect. So they're unpaused and back to go through answers. So first question. Maisie buys 5 boxes of eggs. Each box contains 12 eggs. She uses 18 of the eggs. What fraction of the eggs does she have left? So we know we've got 5 boxes and there are 12 in each one, so we need to find out how many eggs we've got in total. So we do 12 times the 5 boxes equals 60. She uses 18 of them. So I'm going to do this fraction-wise. So I'm going to put 60 over 60. And I'm going to take away 18 over 60 because there were 18 eggs used. And I'm putting it in fractions because there's what fraction of the eggs does she have left. If I do it from the beginning, it's easier. So 60 over 60, take 18 over 60 equals 42 over 60, which you would have got marked for, absolutely fine. But you could have simplified it down to 7/10. You've got 7/10 of her eggs left. The next one, which of the fractions add up to 1? Now you needed to make all of the denominators the same. So you needed to make them all 10 and then work out which ones add to make a numerator of 10. So it was 1/5, 3/10, 1/2, because that gave you 2/10, 3/10, 5/10, which adds to make 10/10, which is 1. This one, which two of the fractions below have the greatest difference? So difference, we're looking at subtraction, or we're looking at the numerator to be as far away as possible from each other. So they all go into 18. So we've got 8/18, 6/18, 3/18, 7/18. To work out the greatest difference, we look at the numerators, which two are furthest away, 3 and 8, which means it was 1/6 and 4/9. Hopefully we did okay on those ones. Now today we are looking to calculate using pie charts. So we're going to be looking at pie charts to answer different types of questions. Star words, we're going to be using percentages and fractions in our pie charts. Calculate, and the important number we're going to be focusing on is 100%. That's going to be our whole. So let's have a look at a problem. As I said, we're going to be looking at solving problems like the one we've got below. So 750 people were asked to name their favorite color. Here is a pie chart of their favorite color. The options were red, blue, gray, and green. And it says how many people preferred gray. Now the percentages are already done for you. 50% preferred red, 35% preferred green, 10% preferred grey, 5% preferred blue. So to work out how many people preferred grey, we take the whole amount of people we've got, the 100%, which is 750, and we want grey, which is 10%. So 10% of 750, we divide it by 10, which is 75. That is the number of people who preferred grey because we found 10%, so it was 75. So you look at the total number and you look at the percentage you've got and you divide to make that percentage. Now that one went into 10%, so that's quite nice. Sometimes they won't go into 10%, and there are two different ways we can do it. So 100 people were asked to name their favourite sport. 100% is 100 people. Rugby, 30%. Cricket, 10%. Netball, 25%. Hockey, 35%. And it says how many people preferred hockey. So this one we need to think logically, because we can't just divide by 10 now. So we know that 100% is 100 people, and we're being asked to find 35%. Now, there are two ways we can do it. We can find 1% and times that by 35, or what percentage we need. So to do that, we do the 100 people, and to find 1%, we divide by 100. So 100 divided by 100 is 1. And then we times that 1%, which in this case is 1, by whatever percentage we want to find. So we want to find 35%. So 1 times 35 equals 35. So 35 people preferred hockey. Now in this case, that's probably the easiest method to use. But if a number were 170 or 180, it might not be such a nice multiplication. Still very doable, still a good method to use, but if you don't like that one, you can use a method we practiced last term, which is building a percentage. So we want to build to make 35%. So we do that by finding 10% and 5%, and then we can build towards it. So 10% was 100 divided by 10, which is 10. 35%, so we need 30%, so we times our 10 by 3 to get 30. And then we want to add 5% to that. Now 5% is just 10% cut in half, so half of 10 was 5. So we do a 30, add the 5 for 35. Again, it's an easy method to use in this case where it's 100. Sometimes building the percentage method is better when it's a tricky multiplication, but if you can do it, dividing by 100 and then timesing by the percentage you want makes life a lot easier. What I want you to do for me is to go on Mathletics and complete the pie chart problems you've been set for today. Then you need to come back and we've got a couple of problems to go through before we finish off. So off you go and do your Mathletics, please. Okay, we should be back, so let's move on. And your final part of today, of your taught session, I would like you please to look at these two questions, these two problems which require some logical thinking and some solving. They're all about pie charts. Some of them will be larger than others. That is annoying. So the first one might take you a little bit longer. And the second one requires more of a logical thought process. Don't be caught out. Have a go at both of these in your home learning book, please, and then we'll mark them once you've had a go. So go and have a go at these two in your home learning book using what you've learned today. Good stuff. We should be unpaused and back. So let's go through these answers. So first one said, 15 people in this survey have no siblings. Use this information to work out how many people took part in the survey altogether. All right, so we've got to do that. So 15 people have no siblings. No siblings is 5%. We know we're building to 100%. So 15 is 5%. That means for double that, 10% would be 30. And therefore, we can use that 10% times it by 10, or we can find 1%, which is 3, and times it by 100. Either way, 300 people took part in the survey. So you either find 10% or 1%, and then you find your 100%. Perfect. Next part of the question. Now work out how many people each segment of a pie chart is worth. Can you represent the information in a table? Now I'm going to be really honest, we have not made a table. I've just put the answers here, so if you have, that's fine. So no siblings, we're told, is 15. Good. Then one sibling is 9%. We've already got 1% here, so 1% of the total population of this chart is 3. 9% would be 9 times 3, which is 27. So 27 people have one sibling. 10% was 30, so 2 siblings is 30. 3 siblings was 17%, so we times that by our 1%, which was 3. 3 times 17 is 51. So 51 people have 3 siblings. This green section here, 28% had 4 siblings. So again, we just times 28 by 3, our 1%. 3 times 28 is 84. So 84 people had that. And then the last one, 5 siblings, was 31%. Again, we times that by the 1% value, which is 3. 3 times 31 is 93. So there are your answers there. To the first bit, total number was 300. And then how many people each segment's worth is all here. So 15, 27, 30, 51, 84, 93. Hopefully we did okay on that one. The next one, 120 boys and 100 girls were asked what was their favourite subject. Here are the results. Boys' favourite subjects, 50% maths, 15% English, 35% science. Girls' favourite subjects, 50% maths, 20% English, 20% science. That shouldn't say 50, that should say 60. So let me double check that I gave you the right question. Okay, do not panic at all. We'll pause. Okay, so I've just done a little look at what went wrong there, and it turns out that I've had a bit of a computer error and it's moved the 60% because the question itself was wrong. So I corrected it and it's moved the 60% down to the bottom of the chart for some reason. So it looked like this was 50%. So what I'm going to get you to do is, so sorry if you've already had a go at it, but have a go at this again with the girls' favorite subject of 60% here. Okay, so have a go at this one again. Pause and have a go. If you realized it was 60%, I've already done it. Great, we'll go through the answer in a second. If you haven't, have another go at this with this one being 60%, and we will be going with that. So pause it, have a go, and then we'll go through the answers to it. So hopefully my computer's kept the answers here. Yes, it has. So we've got 60% now. So 50% of boys like maths, 60% like maths of the girls. Jack says more girls prefer maths than boys because 60% is bigger than 50%. Do you agree? So 50% of the number of boys, which is 120, is 60. Now the number of girls was different. So there are 100 girls and 60% of 100 is also 60. So Jack is incorrect because the same amount of boys and girls like maths. Okay, so sorry about the computer error there. Hopefully we got that question and you were able to solve it. To finish today, I would like you to go into your TT Rockstars and give yourselves about 10 or 15 minutes practice if you can at your times tables, because when you come back, we're going to have a practice, something they're going to be doing in year 4, but it's the times tables assessment. It's a proper serious assessment that they do in year 4. And I thought, why not? We'll have a go at it and see what our tables are like after we've been in lockdown. So all this week, we're going to have real focus on our times tables, so you're able to have a good go at that. So go and practice for me, and we'll have another session tomorrow.